Alright, good morning everybody. Today's lesson is over the Pythagorean Theorem. And when you were in junior high, you learned that the Pythagorean Theorem only works for right triangles. You must have a right angle in the triangle in order for this to work. The Pythagorean Theorem is a squared plus b squared equals c squared. And what in the world that means is that if you have a right triangle and we put this corner right here at the origin on the coordinate plane, and we say that we go over some distance, and we're going to call that distance A. That would put this point at the point A, 0. And we're going to go up on the y-axis a distance of B, which would put this point at 0, B. We can then call this third side C. We don't know what it is, but we do know our handy-dandy distance formula, and we would know that in order to find the value of C, we would need the square root of, subtract the x's, 0 minus a, and we square that, and we get a squared, plus, do the same thing with the y's, b to 0 is b, square that, we have b squared. If you want to move the square root to the other side, all you need to do is square a square root in order to cancel. And as soon as I do that, I now have c squared equals, and the square root cancels, and there's my a squared plus b squared. So that is proof that if you have a right triangle, because it's placed at the origin and goes perfectly horizontal and perfectly vertical, this Pythagorean theorem works. You can find the hypotenuse side by doing a squared plus b squared equals c squared. Now the key, guys, is that you have to be sure that you have the hypotenuse side by itself. You must be very, very careful. So in this problem, if we are going to find the hypotenuse, I will call it x. We will take 12 squared, add that to 5 squared, and we end up with x squared. 12 squared is 144. 5 squared is 25. That will be x squared. Add those together and you have 169 equals x squared. And then you need to find the square root button on your calculator. Sometimes it involves the shift button or the second function button. But find the square root button, type in the square root of 169, and you should get an exact answer of 13. So for this problem, the length is 13 meters. Okay. Here's a real world problem involving a ladder. I like to draw a picture. Of course, you guys should be used to that. And my right triangle is going to represent the house going up and down, the ladder that is leaning. So this is going to be my ladder, and this is going to be my house. The wall of my house should be vertical. Let's hope so anyway. Okay. For stability, the base of this 17-foot ladder, so it's a 17-foot ladder that's leaning, and it should be placed 4 feet from the house. So from the house to the base of the ladder should be 4 feet. Question is, how far up the house is this ladder going to reach? That we will call x. So to set up this problem, I have x squared plus 4 squared equals 17 squared. 17 is the hypotenuse because it is opposite the right angle. This would then give me x squared plus 16 equals 289. If you square 17, you get 289, which gives me x squared equals, if you take 289 and you subtract off 16, you will get 276. Hit the square root button on your calculator, and we have an approximate answer of 16.6 feet. That is approximately how high up the house, so he can reach about 16 feet, 16 and a half feet up the side of the house. Maybe he's hanging Christmas lights. Or maybe he's got to fix a gutter. Who knows? Okay, this next one is where we go 3D. We are going to find the length of the diagonal in this rectangular prism, and we're going to find, let's see, we want to find B to H. That is this segment right here. In order to do that, we have to create a right triangle that goes this direction, but we only have one number on the side here, and that number is 12. We don't know this one. In order to find that one, we have to go along the bottom and create a second right triangle. So, we have two different right triangles that we are looking at. The first one is one that I am going to pull from the floor of this shape, and let me spin this around so it looks a little bit more like what we're looking at. Okay, here's my right triangle. This side is 3, this side is 4, and I am looking to find this side right here. I'm looking for this side. Set up the Pythagorean theorem. That would be 3 squared plus 4 squared equals x squared, because x is the hypotenuse. That would be 9 plus 16 equals x squared. 9 and 16 is 25. 25 equals x squared, and the square root of 25 happens to be 5. So now that I have found that that one is 5, now I can transfer that answer over to the blue triangle. And again, I'm going to spin this around so that it looks a little bit more like the one that's in the picture. And now I have 12 coming up the side here. I just found this, which was the hypotenuse in the first triangle, but it's actually a leg in the second triangle, and it has a length of 5. And I am now trying to find the new diagonal or hypotenuse length, which this time I'm going to call it y because it is a different value. So now I'm going to set up my Pythagorean theorem with 12 squared. Just realized that I had not shown you that picture. So here we go. I moved the x value that we just found down here below. 12 is my vertical value, and I'm going with 12 squared plus 5 squared equals y squared. 12 squared is 144. 5 squared is 25. That is supposed to equal the hypotenuse squared. That gives me 169 equals y squared, and the square root of 169 happens to be 13. And that is the answer that I am looking for. That is the length from B over to D. On the original problem, that was from here to here, and that has a length of 13. But first I had to do this green triangle on the floor, which was a 3 and a 4, and I had to find this length was 5. Then I put 5 on my new triangle with 12 up the side and found this one to be 13. Here's another example of a 3D. This would be a hexagonal pyramid, and we are going to find the slant height, which just means this part that is leaning from the tip down the side. We're going to find that length right there. It's called the slant height. According to the given information, the height from V to P is 12. And let's draw another triangle outside here so that it looks a little bit more clear than inside that 3D figure. And we'll flip it around here again. So it's telling me that the height from V down to P, that's 12. And then it gives me this weird word. It says the apothem is 6. Now, just trust me for now. The apothem, no clue where that name came from. Maybe you can Google it. That is the name for the segment that goes from the middle of the base over to the middle of a side of a three-dimensional figure. So anyway, I've told you that it goes from R over to P. So you can clearly see that on your picture, that it's going right here from point R over to point P. That has a length of 6, and you are supposed to be finding the slant height, which would be this one. Pythagorean theorem, 6 squared plus 12 squared equals x squared, which gives me 36 plus 144 equals x squared. 144 plus 36 is going to give me 180 for x squared. And we will have to round that answer off approximately 13.4 centimeters for our value of x. Okay? So review of the Pythagorean theorem that you learned when you were in junior high. A squared plus b squared equals c squared only works for right triangles. Please make sure that the hypotenuse side is always the longest side. You have to look opposite the 90-degree angle in order to find the hypotenuse. No matter how the triangle is turned, you have to find the 90-degree angle and look opposite. Okay. Then we're going to stretch your thinking a little bit by giving you three-dimensional figures, and you may have to look at two different triangles and work from one to the other. Or it could just be that I'm going to give you one three-dimensional figure and just ask you to see the triangle that is standing up. Okay, so a squared plus b squared equals c squared, where c is always the hypotenuse side.